6% of the world's CO2 emissions comes from buildings. In the EU, energy use in buildings accounts for as much as 36% of greenhouse gas emissions. That is why the energy-efficient renovation of buildings is a key aspect of the European Green Deal. External thermal insulation composite systems are among the most effective insulation options. One example from Germany, just under 1 billion square meters of external insulation has been installed there since 1980. That has saved some 92 billion liters of heating oil and 279 million metric tons of CO2. Model trials conducted in Dubai have shown that in hot climates, insulation can cut energy use for cooling by up to 60%. An external thermal insulation composite system consists of several elements. Each element plays a specific role, and all elements must be compatible. The adhesive mortar must create a secure bond between the masonry and the insulation panel. The mesh, the base coat, and the finishing coat must protect the system against damage from sources like hailstones, physical impacts, or thermal stress. That's why the adhesive mortar, the base coat, and the finishing coat are polymer modified with Finipos, dispersible polymer powders. The mortar, composed of cement and fillers, is mixed together with Finipos polymer powders. When water is added, the dispersible polymer powders form polymer bridges. This enhances two key properties of a mortar: adhesion and flexibility. In the adhesive mortar of an ETICS, adhesion is paramount. While unmodified adhesive mortars will adhere to mineral masonry via the cement crystals, they cannot provide a reliable bond to insulation panels that are usually made of organic materials. Polymer modification establishes secure adhesion to both materials. The cohesive failure test proves it. Unmodified mortar, shown left, separates cleanly from the surface of the insulation material. Polymer modified mortar, shown right, adheres so strongly that the failure occurs in the insulation material. For the base coat and the finishing coat, the key property is flexibility. While unmodified plaster forms a rigid matrix that will break on impact, the flexible polymer strands in a modified plaster absorb such impact energy. This can also be demonstrated in trials. Even movements or stresses caused by large temperature fluctuations in the construction materials can be absorbed through modification. That is crucial because damage to the top coat allows moisture to enter, rendering the entire system incapable of thermal insulation. With Finipos polymer binders and Silres silicone resins, the top coat can additionally be made water repellent. That amply protects the entire system against the effects of weathering. Specific Finipos dispersible polymer powders are optimized for use in external thermal insulation composite systems and significantly enhance their longevity and functionality. Thus, they help conserve energy and lower CO2 emissions for the long term.
Wacker, creating tomorrow's solutions.